Hi, I'm Deborah Fisher, and I'm a professor of astronomy at Yale University. My job is to find planets orbiting nearby stars, and today we're going to introduce a new project for you called Planet Hunters. In our solar system, there are 8 planets that orbit our star, the Sun. We've been detecting planets orbiting other stars as well. Since 1995, more than 500 planets have been found orbiting other stars. There are a few techniques to find extrasolar planets orbiting other stars. The technique that I use is called the Doppler technique, and basically as the planet orbits the star, it causes the star to wobble around a common center of mass with the planet. So we can't see the planet with my technique, but we see the star wobbling toward us and away from us. Another technique is called the transit method. And with this method, the planet passes in front of the host star and causes the starlight to dim ever so slightly. It takes about 3 hours for a planet to go across the face of its star, and so for 3 hours we'll see a little dip in the brightness of the star. You can imagine that if the planet is very large, the depth of that transit will be much deeper. In March of 2009, NASA launched the Kepler mission. The principal investigator, Bill Barucki, had been planning and working to design this mission since the mid-1980s. And so it was an enormous feat when it finally launched. The great thing about Kepler is that because it's above the Earth's atmosphere, it gets a very clear view of the star field. So Kepler is staring at a field of stars near the constellation Cygnus, where there are 200,000 stars in this field. And unblinking, the telescope stares at these same stars and takes measurements every 30 seconds and watches for a slight dimming in any of these stars as a planet passes in front of it. With Kepler, we hope to determine Eta sub Earth, the frequency with which Earth-like planets form. The first data from the Kepler mission has been made available to the public, and astronomers have been absolutely amazed by what they're seeing. The time series snapshots of stars that are taken by Kepler is called a light curve. So we'll see the changing brightness in a star either because a planet is transiting in front of the star, or because the star has spots, or because the star is expanding and contracting, or because there are flares on the star. And it's the unprecedented precision of the Kepler data that has absolutely blown away astronomers. As soon as we saw the data, we realized that this would be an interesting experiment for the citizen scientists.
Galaxy Zoo was the original citizen science project where we took images taken by a robotic telescope in New Mexico at Apache Point, which had taken data for over 1 million galaxies. The problem was no one person or even team of scientists was able to really sort through all of them by hand and take a good look at what was out there. In recent years, data sets that astronomers and other scientists have been working with have gotten bigger and bigger, and so the old techniques of getting a few scientists together to sort through it by hand have been getting harder and harder. What many scientists do now is they just run sophisticated computer programs. Well, a computer can only ever look for what you basically teach it to look for. And so if something doesn't quite fit or the data is not very good, it can be very challenging for your automated routine to really determine what it is you're looking at. So the reason we turn to the internet is because we just need more people, we need more human brains. And so what we've built through the Zooniverse, through our experience with Galaxy Zoo, we've essentially built the world's largest distributed supercomputer dedicated to pattern recognition. We've linked up over 300,000 human brains and turned it into a science machine. When we launched the original Galaxy Zoo, we thought that maybe there's a few dozen or 100, or maybe if we're really lucky, a few thousand people across the internet who'd be interested in doing this. And so our expectations for how long it would take us to sort through 1 million galaxies were very low. We thought it would take many years to do this. And instead, When we launched the website in 2007, within a few hours so many people had logged on wanting to classify galaxies that it actually melted one of our servers and the website was knocked offline. So Galaxy Zoo has been a huge success. Over a span of almost 2 years, every single one of these 1 million galaxies has been viewed more than 70 times by the Galaxy Zoo users.
We think it will be great to involve citizen scientists in this project. It'll be sort of man against machine, and it's a great experiment to see how well human beings can do. The human brain is incredible at pattern recognition. So we think that against the background of these very wildly varying light curves with spots and everything else, that you'll be able to pick out tiny transit events. With Planet Hunters, citizen scientists will be able to evaluate one of these light curves in a matter of seconds. We'll ask you to do 3 things. The first step is check to see if there's an offset in the data, a sort of glitch, and let us know about that so we can go in and fix it. The second question will be, is the star variable? Does the light look sort of scattered but constant, or do you see cyclical variations in the star that have periods of days or months perhaps? And then the third question will ask you to actually try and flag any transit events that you see. So if you see a series of low points, a little like rain almost, these look like raindrops falling down, then we'll ask you to draw a box around these points and flag it as a prospective transit. The excitement over Kepler is incredible because we're pretty sure that in the next 2 or 3 years we're going to quadruple the number of planets that have been found. And more importantly, we're going to be finding planets that are closer to Earth, the size of Earth, rather than gas giant planets like Jupiter or Saturn or even Neptune. So for citizen scientists, the treasure hunt is clearly going to be trying to find the smallest transit events possible. And the planets that are going to be the most difficult to find are going to be the smallest planets and the planets that have longer orbital periods. These are planets that are farther away from their host stars.
So the point of citizen science is not to sort of provide entertainment or just provide education. The point of citizen science is to actively involve people in real research. So when you join Planet Hunters and you go look at light curves of stars in our Milky Way and investigate them, you're contributing to actual science and you might make an actual discovery.